Welcome to the Explainer. So, today we're unpacking a massive historical paradox. When you picture the legal world, you're probably thinking of slow bureaucracy, right? Just mountains of paperwork. Well, what if I told you that this very same world of law actually engineered the foundational infrastructure for our lightning fast modern digital economy? I know, it sounds totally impossible, but the historical record actually proves it. Okay, let's dive right into this staggering number: $20 trillion. To put that into perspective, according to recent data, that represents the current scale of the global digital economy. We're talking roughly 15 to 20% of the entire global GDP here. And this massive economic engine, it's built on layers of highly specific computer code and protocols. Today, we're going to trace exactly who invented those foundational layers. We often contrast the really expensive, manual, kind of horse and buggy friction of traditional legal practice with the totally frictionless electric car scale of modern tech. Because in traditional law, human brains are doing all the heavy manual computation, right? That's exactly why it's so incredibly expensive. But there's this hidden connection here. As you'll see, highly trained legal minds actually invented the frictionless tech that acts as our modern engine. Now, before we look at the historical proof, we really need to quickly define a concept that unites these two worlds. It's called legal engineering. Basically, it's an emerging discipline that deconstructs traditional jurisprudence, which is, essentially just the study of human relationships, and it reconstructs it using scientific law. The goal is to create applied, automated technological solutions. In other words, it takes all that heavy mental labor of law and turns it into highly mechanized systems. Let's see how this all builds across a pretty undeniable historical lineage. We're going to look at three brilliant legal minds who stepped outside of the courtroom to literally change the world. We've got Pierre de Fermat back in the 1630s, Charles Goldfarb in 1969, and Nick Szabo in the 1990s. Moving to case study 1, the pragmatic magistrate. So our first hidden architect is Pierre de Fermat. Now, you might know him as a famous mathematician, but back in the 1630s, he was actually a working lawyer and a government magistrate down in Toulouse, France. Math was, well, practically just a private hobby for him. In the courtroom, Fermat operated under this standard judicial pragmatism. It's summed up by the legal maxim, de minimis non curat lex, which basically means the law does not care about trifles. Unlike philosophers of his era, guys like Descartes, who demanded absolute, pure logical perfection and actually mocked Fermat's work at first, calling it groping in the shadows, Fermat was totally willing to accept a lossy or approximate solution just to move a case forward. And this brilliantly illustrates how Fermat's legal training actually led to a massive mathematical breakthrough. He took that courtroom pragmatism and applied it directly to his math, inventing a technique called adequity, basically by dismissing residual variables as mere trifles, saying they were close enough to zero to just ignore entirely. He figured out how to locate maxima, minima, and tangents. That pragmatic, strictly legal mindset of approximate equality, it literally became the direct foundational step for modern differential calculus. Absolutely wild. All right, on to case study 2, the contract redliner. Jumping forward to 1969, we meet Charles Goldfarb. He was a Harvard Law School graduate who ended up working at IBM. Now, Goldfarb was trying to solve a very specific legal supply chain problem. At the time, lawyers really needed an information system to help them search through past court rulings, and they needed to automatically format their legal briefs so they could share them across totally different, often incompatible computer systems. Basically, he needed a way to represent data that was completely independent of any specific application. So here is the crucial point. Goldfarb tackled this problem by modeling a generic tag structure directly after the way lawyers traditionally mark up and redline contracts during negotiation. This invention became known as Generalized Markup Language, or GML. Over the years, GML evolved into the SGML standard, which Tim Berners-Lee eventually stripped down to create HTML. Yeah. Think about that next time you load up a web page. The foundational DNA of the entire World Wide Web was originally designed by a lawyer who was just trying to automate contract markups. It's a real game changer when you realize that. Next up, case study 3, the protocol scholar. Finally, we arrive in the 1990s with Nick Szabo. He's a pioneering computer scientist and a legal scholar. Szabo really wanted to bring centuries-old contract law into the new, totally trustless digital world, so he officially coined the term smart contract. To explain it, he famously used the humble vending machine as this primitive example. Think about it. A vending machine physically embeds contractual clauses right into its hardware. You put a coin in, and it dispenses a soda. The actual physical mechanism makes breaching the agreement, like trying to steal the soda, prohibitively expensive. Well, Szabo wanted to do exactly that, but with software. Just look at how perfectly Szabo mapped traditional common law doctrines directly onto decentralized computer networks. It's fascinating. He took consensus ad idem, which is the meeting of the minds, and he mapped that straight to deterministic code execution. Then he took privity, the legal idea that contract info is restricted only to the specific parties involved, and mapped it to cryptographic encryption. And for consideration, the valuable exchange part, he utilized digital cash and network gas fees for that. He essentially translated messy, wet human law into precise, dry machine code. This brings us to the legal engineering revolution. When we pull all these historical threads together, we realize something pretty profound. Our modern digital society is, at its core, a true legal engineering triumph. I mean, Charles Goldfarb and Nick Szabo are the but-for creators of a massive chunk of global wealth. Seriously, without Goldfarb's markup language, we wouldn't have the internet as we know it today. And without Szabo's smart contracts, we wouldn't have Ethereum or the modern decentralized web. Together, these legal engineers synthesize the rigid precision of computer code with the pragmatic realities of human relationships to literally construct a digital economy worth over $20 trillion. So how exactly did they unlock so much value? Well, it was by upgrading the precision of language and mechanizing all that expensive mental labor. This achieves what Nick Szabo refers to as social scalability. Basically, by minimizing the amount of trust required to do business, strangers from all over the globe can securely interact. Whether you're buying a digital asset or just signing an online agreement, you can do it all without needing those expensive, centralized intermediaries in the middle. It's a huge leap forward. Which brings us right to the future. We're already seeing these concepts applied in real time to new sovereign concepts, things like network states and experimental zones for polycentric law, like Prospera down in Honduras or the Zuzulu movement. So I want to leave you with this provocative thought to take away from today's explainer. If this is what legal engineering did for the internet, literally creating $20 trillion in global value, what entirely new societies and economies is it going to construct tomorrow?